Welcome to the Introduction to Information Security. In this presentation, we will explore the fundamental concepts and importance of securing information in today's digital age. Our learning objectives include defining information security, understanding its modern-day relevance, recounting the history of computer security, and explaining key terms and concepts. We will also discuss the role of security in the system's development life cycle and the roles of information security professionals. A hacker is someone skilled in computer programming and cybersecurity, exploiting system vulnerabilities. Hackers can be categorized based on their intent: ethical hackers, malicious hackers, grey hat hackers, and state-sponsored hackers. Hackers often target the weakest link in the security chain, which is usually people rather than technology. Kevin Mitnick, a renowned hacker, emphasized the importance of addressing human vulnerabilities in security. Kevin Mitnick was a famous American computer security consultant, author, and convicted hacker. He is best known for his high-profile arrest in 1995 and his subsequent work in helping organizations improve their security. Information security ensures that information risks and controls are balanced. Security professionals must review the origins of this field to understand its current impact on information security practices. The history of information security began with the development of mainframes and code breaking during World War II. Physical controls and measures to prevent theft, espionage, and sabotage were established early on. The Enigma machine, used by Nazi Germany during World War II, was a sophisticated cipher device. Its codes were eventually broken by the Allies, significantly impacting the war's outcome. In the 1960s, the US Department of Defense's ARPA began exploring networked communications, leading to the creation of ARPANET, the first public packet-switched computer network. The ARPANET program plan, developed in 1968, outlined the objectives and technical requirements for creating a networked communication system, laying the groundwork for the modern Internet. ARPANET's popularity grew, but so did its security issues. There were no safety procedures for dial-up connections, and user identification and authorization were non-existent. The RAND report R609 initiated the study of computer security, defining controls and mechanisms for protecting multi-level computer systems. The scope expanded to include data safety, access control, and personnel involvement. The RAND report R609 illustrated various computer network vulnerabilities, highlighting the need for comprehensive security measures to protect against different types of threats. MULTICS, developed in the 1960s, was the first operating system designed with security as a primary goal. It was a collaborative effort by MIT, GE, and Bell Labs, focusing on time sharing and mainframe security. In the 1990s, computer networks became more common, and the Internet emerged as a global network. Initially, security was a low priority, but events like the DEF CON conference highlighted the growing importance of information security. DEF CON is one of the world's largest cybersecurity conferences, bringing together experts to discuss and explore various aspects of cybersecurity. It fosters collaboration, showcases emerging trends, and encourages hands-on learning. The Internet now connects millions of computer networks, many of which are unsecured. The growing threat of cyber attacks has increased the need for improved security measures to protect data and systems. Security involves being free from danger or harm and taking actions to protect against threats. Organizations must implement multiple layers of security to safeguard operations, infrastructure, people, functions, communications, and information. Information security protects critical elements, including systems and hardware that store and transmit data. It encompasses information security management, data security, and network security, based on the CIA triangle. The CIA triangle stands for confidentiality, integrity, and availability. These principles ensure that information is protected from unauthorized access, remains accurate and complete, and is available to authorized users when needed. Information security is built on three main pillars: computer security, data security, and network security. These pillars are supported by policies that ensure confidentiality, integrity, and availability. A computer can either be the subject or the object of an attack. When it's the subject, it actively conducts the attack. When it's the object, it is the entity being attacked. Access refers to the ability to use or modify an object. An asset is the resource being protected. An attack is any act that can damage or compromise information. An exploit is a technique to compromise a system. Exposure is the state of being exposed. Loss refers to damage or destruction of an information asset. Risk is the probability of an unwanted occurrence. A threat is any danger to an asset. A threat agent is the specific instance of a threat. Vulnerability is a weakness that can be exploited to cause harm. This diagram illustrates various key concepts in information security, including threats, exploits, and vulnerabilities, and how they interact with each other. The value of information is derived from its characteristics: availability, accuracy, authenticity, confidentiality, integrity, utility, and possession. An information system comprises software, hardware, data, people, procedures, and networks, all working together to enable business operations. Achieving perfect information security is impossible. It's a process. Security must balance protection and availability, allowing reasonable access while protecting against threats. Information security can be implemented using either a top-down or bottom-up approach, each with its own advantages and challenges. The bottom-up approach relies on the technical expertise of individual administrators. However, it often lacks participant support and organizational staying power. The top-down approach is initiated by upper management, setting policies and procedures. It often involves a formal development strategy like the Systems Development Life Cycle, SDLC. The Systems Development Life Cycle, SDLC, is a structured methodology for designing and implementing information systems, ensuring a comprehensive security program. The SDLC waterfall methodology involves sequential phases: investigation, analysis, logical design, physical design, implementation, and maintenance. The investigation phase identifies the problem to be solved, specifies objectives and constraints, and conducts a feasibility analysis to ensure the project is worthwhile. During the analysis phase, assessments are made to determine what the new system should do and how it will interact with existing systems, ending with documentation of findings. In the logical design phase, information from the analysis phase is used to create a solution system. Technologies are defined, and cost-benefit estimates are generated. The physical design phase involves selecting specific technologies and components, making make or buy decisions, and presenting the solution for management approval. During implementation, software is created or purchased, components are tested, and users are trained. Supporting documentation is also created. Maintenance and change is the longest and most expensive phase, involving tasks to support and modify the system throughout its useful life. The cycle continues until a new project is needed. The same phases used in traditional SDLC can be adapted to support specialized implementation of an information security project. This involves identifying specific threats and creating controls to counter them. The Security Systems Development Life Cycle, or SEC-SDLC, is a coherent program rather than a series of random, seemingly unconnected actions. A diverse information security program requires a wide range of professionals. Senior management plays a key role, while additional administrative support and technical expertise are essential for implementing the details of the information security program. The Chief Information Officer, or CIO, is a senior technology officer responsible for advising senior executives on strategic planning. The Chief Information Security Officer, or CISO, is primarily responsible for the assessment, management, and implementation of information security in the organization, usually reporting directly to the CIO. An information security project team consists of individuals experienced in various technical and non-technical areas. These include champions, team leaders, security policy developers, risk assessment specialists, security professionals, systems administrators, and end users. Data responsibilities are divided among different roles. The data owner is responsible for the security and use of a particular set of information. The data custodian handles storage, maintenance, and protection of information. Data users are end users who work with information to perform their daily jobs, supporting the mission of the organization. Information security implementation is often described as a combination of art and science. As in art, there are no hard and fast rules or universally accepted complete solutions, and no manual for implementing security throughout the entire system. As a science, information security deals with technology designed to operate at high levels of performance. Nearly every fault, security hole, and system malfunction results from the interaction of specific hardware and software. If developers had sufficient time, they could resolve and eliminate these faults. Security as a social science examines the behavior of individuals interacting with systems. Security begins and ends with the people who interact with the system. Security administrators can greatly reduce levels of risk caused by end users and create more acceptable and supportable security profiles.